Hello everyone, this is Miss Hanley. These are notes number 9 for Unit 2, Algebra 2, Systems of Equations. This is the last piece of just systems of equations. So after this video and the completion of this assignment, you should be looking to take the next quiz, and then you can move on to the last third of topics for this unit. So let's begin. And before we start working, you will want to actually print out the assignment or get a paper copy from Miss Hanley before watching this video. That way you can fill it in with me at the same time. Okay, let's go back and talk about some of the types of equations that you have been working on throughout this unit. The first type is standard form equations. And so by now you guys all know standard form is your ax plus by is equal to c. And a, b, and c, those just represent coefficients. Those are just numbers. And then x and y are always on the left. So we've been working with standard form quite a bit. And now we're going to start applying this to word problems. So you will either be building your equations into standard form or into slope-intercept form, and depending on the type of information they give you, one type is going to be easier to use than the other. When you're trying to identify something that would use a standard form equation, you are going to want to think about how these values are set up. So we need an a, a b, and you can see that those two things are getting added up and they equal something on the right-hand side. So when you're given a word problem where they give you two different values or two different prices or something along those lines, if they're saying, you know, this piece costs 30 cents and this piece costs 50 cents, that's usually what your A and B will represent. And this number on the end here is going to be the total. So 30 cents for this one, 50 cents for this one. Together, they've sold $100 worth, something like that. So something that represents a total is what you're going to put in that last value there. And then on the left, it would be the two different values that would make up that total. So standard form equations, if you read a problem and you see two different items that are going to add up and give you a total, and it doesn't have to be money, it could be anything, that's when you want to choose the standard form equation. All right. On the other hand, we have slope-intercept form, which again, you guys are pretty comfortable with at this point, y equals mx plus b. If you think about this from a graphing standpoint, the b value, that's always your y-intercept, right? Well, the y is your starting value. The y-intercept is your starting value. That's where you begin. Okay, so if you have a one-time cost or a one-time value, that would be sort of the basis or the jumping off point, that's going to represent the b or the y-intercept here. So that would be the starting or initial value. Here, instead of starting, let's write that as initial value. For example, if I have to pay a flat fee of $50 for someone to come work on my plumbing, and then it's $30 after that for each additional hour, the flat fee or the one-time cost, that's my initial value, and then it would go up from there. In that same respect, the m is not going to be the number that you only use once. It's going to be a number that keeps occurring. So the m value is your slope or your rate of change. And when you see the word per, you'll see that a lot in word problems, right? $30 per hour, 5 cents per minute, 60 gallons per mile, something like that. You are going to be using that as your slope. Because that's a value that's changing every time. And so if it's $30 per hour, it would be 30 times x, where 30 is the dollars, per sort of means to multiply, and then the hours that are changing, that's what your actual variable is representing. So you could substitute in 1 for your hours. It would cost $30. You could substitute 2 in for the hours, it would cost $60, etc. So anytime you're given a slope and intercept type equation where you have an initial value and then some value that's going to be changing, that's when you'll fill in slope-intercept form. So you're going to be building these equations from scratch, from just information given to you. And these are the 2 types that you want to stick to. Rarely will you start in point slope form, but it can happen. All right. And then just a little recap, we want to remember when we should be using substitution and when we should use elimination. And the last practice that you did should really help you out with this. But remember, substitution is when you have one equation solved for a variable. And so depending on which equations you built, that will determine the method you use to solve. If you create 2 standard form equations, you're probably not going to use substitution. You would use elimination. So you want to use that when your equations are in standard form. And all that really means is that they're lined up. So the x's are above the x's, the y's are above the y's, the equal signs line up, and the just constants line up. And once you've figured that out, then you can actually go ahead and solve your problems. So we're going to try just a few of these together, and then you can finish up the rest on your own. Okay, so let's look at the first one. The first type is a translating problem. So you did this back in Algebra 1, where you had to read a statement and create an equation from that. So you want to use all those skills that you had. 3 times the larger of 2 numbers is equal to 4 times the smaller. The sum of the numbers is 21. Find both the numbers. So remember, there's a lot of information in here. You should be looking to create 2 different equations. And with translating, you don't necessarily have to be stuck in standard form or slope-intercept form. You just want to translate the information they gave you. So let's start with the very first step of any word problem is to define your variables. You can use whatever variables you want. Most of the time people stick with x and y, but it could be anything. And when I say define your variables, that just means tell me what they represent. So in number 1, I'll use x and y, and I see 2 different things that we're working with here. The larger of 2 numbers and the smaller of those numbers. So I'm going to make x the larger number. So you might define your variables in the opposite way that someone else does, but as long as you come up with the same answers, it will still be fine. You just might have an x that's a y and a y that's an x, but that's okay. So your larger number is x, the smaller of the 2 numbers is going to be y. So now I at least know what I'm finding, right? So let's go ahead and translate. And if it helps you, underline important words as you go through these word problems to really get a sense of what we're trying to find. So 3 times the larger of the 2 numbers. So I'm just going to stop there. 3 times the larger of 2 numbers. We said the larger number was x, so 3 times the larger would look like 3x. Next I see is equal to. Well, that tells me I need an equal sign. And then 4 times the smaller. Well, the smaller one is y, so we have 4 times y. So bam, I translated the first one, check mark, did that. Now we want to look at the second equation here. The sum of the numbers is 21. Sum of the numbers. Well, sum, if you remember from Algebra 1, means to add. So we want to be adding these 2 numbers together. And yes, you can use a guess and check method, but I really want you guys to be using substitution or elimination to figure this out. So the sum of 2 numbers is 21. Since I don't know what those numbers are, that's where I need to use the variables that I created. Okay, so if I'm adding, sum means to add those 2 numbers. Well, the first number is x, and the second number is y. So x plus y, those have to equal 21. All right, we need to find both the numbers. So at this point, we can look at our two equations and say, am I going to substitute or eliminate? Or you could always graph too. That's certainly an option if you want to. Since we only have one equation in standard form, the other is a little bit jumbled, I'm going to use substitution, which means I need to solve one of these equations for a variable. And just a little hint here, if you solve the first one for a variable, you're going to end up with a fraction. And I know how we feel about fractions. So it might be in your best interest to solve the second equation for a variable, and then you won't have to deal with that. So let's say I want to solve for x. I will take away y from both sides so that x is equal to 21 minus y. So I solved my equation for a variable. Now I can take that 21 minus y and I can substitute that in the x spot in my first equation. So if I rewrite this here, I will have 3 times 21 minus y is equal to 4y. And so now it's just a matter of solving this equation so I can find both values. So 3 times 21 would be 63 minus 3y is equal to 4y. Add the 3y to the other side, and so 63 is equal to 7y. Divide both sides by 7, and so y is equal to 9. So I know that the smaller of the two numbers is 9, but it did tell me to find both numbers, right? So if y equals 9, let me go back to this quick equation here and say, well, then what does x equal? X is 21 minus y, or 21 minus 9, which is 12. All right. And then you always want to go back and make sure that this makes sense, okay? So if you got that the larger number was 9 and the smaller number was 12, you might have gone a little wrong somewhere, or if you just got answers that really don't make sense, you want to go back and look at that. I think our answers look pretty good, and so I'm pretty happy with that. Okay, so let's look at this second problem here. We have 2 records and 3 tapes that cost $31. Then we have 3 records and 2 tapes that cost $29. We want to find the cost of each record and each tape, okay? So when I read through this problem, if it's not a translating problem, you're pretty much going to be either creating a standard form or a slope-intercept form equation. Well, we want to identify if it's standard form that we have 2 values adding up to a total. And if it's slope-intercept, we should have a starting value and then something that's continuously changing. When I read this, 2 records and 3 tapes that cost $31, I see 2 different values and a total, right? A, B, and a C. Then again, 3 records, 2 tapes, and a total of $29. So here's my next A, B, and C. So let's create those equations. Sometimes it's helpful for people to have their variables defined after they create their equations. That way they can sort of see what they're doing. But I think it's really important to try and define those first. So you want to make your variables the 2 different things that you're trying to find. Find the cost of each record and each tape. So then I'm going to say X is the cost of the records. And Y is going to be the cost of each tape. And so from there, let's create our 2 equations. That first one, we have 2 records. Well, that would be 2 times the cost of a record, right? So we have 2 records times the cost, that would be 2x. X is the cost of a record, and I'm using 2. Then we have 3 tapes. Well, 3 times the cost of a tape, which is y, is what I need to add on there. So plus 3y. I'm using plus because I'm finding the total, so I need those things to add together. And finally, the total is in dollars. So you just want to make sure that when you're done, that each piece is going to actually add up to your total. So we have equals 31. And all of that when I say that is that if you have two records, make sure what you're multiplying by is the cost of each record, or vice versa. They could be in a different order depending on what you were given, so that we actually know, how much they're going to cost us, how much the total will be. So then let's make our second equation. 3 records this time, so 3 times the cost of a record. 2 tapes, so plus 2 times the cost of a tape. Those have to equal $29, right? So there are your two standard form equations, and I'm going to leave the rest of this up to you guys. Find the cost of each record and each tape. So now you have a problem where you have two equations in standard form. Probably best to eliminate here. However, if you notice, the x's don't have the same coefficient, and neither do the y values. So if you're going to solve this, you're going to have to multiply both of your equations. And so I know 2 and 3, they both go into 6. So in order to make my top equation start with a 6, I have to multiply by 3. To make my bottom equation start with a 6, I have to multiply by 2. I also want one of them to be an opposite sign so that they will cancel, so I'll multiply by -2. And just don't forget that you're multiplying the entire equations by those values. And once you do that, you can eliminate a variable and come up with your answer. You could also cancel out the y's if you wanted and multiply the top row by 2 and the bottom row by -3. It'll get you the same answers. So like I said, you guys can go ahead and finish that. I won't do that all for you. But you want to make sure that you can figure out, first of all, which type of equation you're creating, and then lastly, which method you're going to use to solve. Okay, and the last example we're going to talk about really quickly together, hopefully you guys haven't given up on me yet, is number 7, the last one. At Hanley's cell phone store, an iPhone 6 costs $100 to purchase, and then the plan is $86 per month for 2 gigabytes of data and unlimited talk and text. So I'm throwing a lot of numbers at you, but you don't necessarily need to use them all, so keep that in mind. McCrum's Mobile provides the iPhone 6 for free, and the same plan is $149.99 per month. After how many months would the plans cost the same amount of money? If you remember the first day we started this unit, we talked about a break-even point, right, with Miss Hanley's dilemma. This is exactly what you're trying to figure out. After how many months are we, sort of breaking even? Are we going to be paying have paid the same amount, no matter which plan we're choosing, and then after that you can sort of pick and choose which method would be better, or which store would be better. But one thing I just want to highlight here is that at Hanley cell phone store, it costs $100 to purchase the phone. That's not something I have to pay all the time, right? I only have to pay that once. And then the plan is $86 per month, okay? So we're paying this $100 fee one time, and then every month you additionally have to pay $86. So if I were going to make an equation, I'm going to choose a slope-intercept form equation because I have a one-time initial cost and I have a rate of change. I see that word per in there like I was talking about before. So my equation would be 86x plus 100. 86 is my rate of change. X is going to be the number of months here. All right, and then y is the total cost for the plan. Okay, and then if you look at the second option, McCrum's Mobile, we have an iPhone 6 for free, so the startup cost is 0, right? But it's $149.99 per month. So my rate of change is 149.99 per month. So per means times, month is our x here, plus 0. Okay, and so you guys can take this and choose to either graph them, or you can do some substitution to find your solution here. But either way, you should come up with the same answer. So figure out how many months it would take, and what is the value when they cost the same, right? And try and figure out, maybe which company it would be better to go with. If you want a graph, you can get some help with desmos.com. Type in those two equations, or you should have this app actually on your iPad. Type in those two equations, find the point of intersection, and read that point. Or if you do it by elimination, you can just do it out by hand here.